Hello, my name is Rob Garner. I'm a computer programming instructor, and today I'm going to overview C++1. So this is what we'll cover. The syllabus is located in Blackboard. Please review it, and we'll look at a few items here. Most of our course material, or if not all of it, will be on Blackboard. You can get to there by going to learn.cnm.edu. And when you go to Blackboard, your courses will be displayed in My Courses. You'll have to log in using your CNM credentials. And when you go to the C++1 Blackboard page, it'll look like this. In my syllabus page, you'll get a schedule as well as the syllabus itself. In addition, most of your materials will be under learning modules. And at this point, you'll have week 1. They're organized as modules, and you have each item is in this navigation element over here on the left. So I'll give you instructions on what to read and the different presentations. Like this is today's presentation. There's some instructions on how to install Visual Studio. Please follow that. You should be getting an email from us with information for your Imagine account. If you don't see that email, please check your junk mail folder in your CNM email address. And then once you get that, follow these instructions to download Visual Studio. You'll need to install that on your home machine in order to do work at home. There's a Hello World exercise. Once you get Visual Studio installed, please complete that demo. There's a video for it, and you can just follow along and basically get Hello World done. I also have an explanation here on how you'll get feedback from me on your programs. Please watch that video as well. And then finally, there'll be a link typically to the current, each week's section will have a link to the program assignments. All the program assignments are located over here under program assignments. But I'll also have a link to that so that you know which program you should be currently working on. And I'll go over how to turn in assignments in another video. We'll be turning them in through Blackboard. And when you get the assignments, you'll get in the specification, it will tell you what to turn in. Typically, I'll ask you to place all of your materials in a zip file and upload it into Blackboard. And we'll do that demo with Hello World does demonstrate how to upload your project. So please view that, do the Hello World demo, and turn in Hello World before the next class. There are certain sets of skills you need to be a developer. It's not just about programming, but it's also about having good documentation in your code, communicating with your customer as well as your fellow programmers. You need to be a quick learner. Programmers are the people who figure out the things that other people cannot figure out. It's your job to be able to learn what you need to know and then employ it. Debugging. You need to be able to take a piece of software, find out what's wrong with it, and correct it so that it works. And this is often a major task that we do in software development. Troubleshooting is part of debugging. figuring out what went wrong. And there's no easy, simple formula for troubleshooting a program. You have to use your creativity and ingenuity in order to do that. And then testing. It's one thing to write code that works, but how do you know that it works? You need to be able to figure out how to create a strategy for testing your software to make sure that you can tell your customer that, yes, this software works. Programming is inherently frustrating. You need to learn to keep your cool. And some of the strategies we recommend are working when you're rested, keep your software simple, give and get help, use your people you know to help you figure things out that you need to know, study and know the rules of the language, learn your development environment. Visual Studio is a great development environment, and it has a lot of tools that can make your life a lot easier. The faster you are writing code, the better programmer or more useful programmer you are. So often those efficiency tools that Visual Studio has are things that you're going to want to know. Understand the problem you're going to solve. It's kind of frustrating when you create a great program and then you find out that it doesn't solve the problem that the customer needed. And and test your software in steps. You can try to build your software write it all in one go, and then run it and try to figure out what went wrong. But it's much better to break the problem up into parts, solve each individual part, and test it a piece at a time. And you'll find that you'll actually be much faster doing it that way. And of course, save early and save often, and back up your program files frequently. It's very frustrating when you've written a nice long piece of code and then lose it. So save and back up often. So what is C++? C was a language that was originally developed in around 1989. It's standardized by the American National Standards Institute, ANSI, at that time. In 1990, it is standardized by the International Standards Organization. These standards are important because there are multiple organizations that write C and C++ compilers, and if there isn't a standard, then you could write code in one format and it wouldn't compile in another format. So those standards ensure that all compilers will work together. In 1990, Bjarne Stroustrup expanded C to include object-oriented capabilities. And he basically took elements of a programming language called Simula, which is a simulation software, and then used that to take C, which at the time was one of the faster, or maybe the fastest, higher level language at the time. And so he made it, he and his team made it a language that was both very fast, but also allowed for a high level of abstraction using object orientation. So C++ is basically C plus object orientation. And C was originally used for operating systems, and it was supplied with Unix. And as C grew in popularity, and it became and computer hardware became more affordable, there are several versions of the C language that were created. In 1982, ANSI standardized it so that it would work the same across multiple platforms. And then there are extensions provided to C language to provide object-oriented capabilities by and those are originally designed by Bjarne Stroustrup and AT&T Bell Labs. And so C plus those extensions is known as C++ language. And then in 1997, ANSI published the final standardized version of C++. So how was C named? C is a result of developing algol, and there was a language that was called B at one point, and so C follows B. So knowing a little bit about the history, the next step is to understand how a C or C++ program is created, and that's through the process of compilation. So we say that C and C++ are compiled languages, and what you'll do is you're going to write code in a text file that is called the source code, and that's a human readable form of your program. You'll then run a compiler on it, or in Visual Studio, we say you build the program, and the build process will actually compile the program, which will validate that your code followed correct syntax, and then it creates an object file and then multiple object files, which will be linked together, which allows you to use libraries created by other people to create your final executable file. The final executable will be a .exe file, which is the thing that you can click on and it will run. So a C++ program must be compiled and linked in order to create the actual executable. Computers don't actually execute text. They have to execute numeric machine code. So really, compilation is a process of taking your text file with your program on it and converting it into an executable machine code file. So building a program requires compilation, linking, and running. And in Visual Studio, you're going to see that the compile and the link steps are combined. They're going to be kind of invisible to you, but that is happening underneath whenever you do a build. And the reason why we need to do this linking and building part is that in the end, the computer only understands a .exe. One of the challenges with developing software is portability and availability. There are C++ libraries that are developed to be cross-platform, which means that you can write code that runs on multiple machines. There's also open source. One of the nice things about C++ is there's a number of open source libraries where programmers have provided you code that's free of charge for you to use in your program, and you are free to use and modify that code. So some of the key features of C++, there's an extended set of data containers. You can work with numeric variables that hold both whole numbers and integral numbers, as well as decimal numbers. You can store characters. We can work with true and false data, or Booleans, and C++ provides us pointers and references which allow us to point to things in memory and work with them. There's a large number of operators in C++. It's one of the best calculators in the world. C++ uses functions, so you can subdivide your program into smaller functional components and then use those functions to build a larger program. And functions are important. They allow us to organize code into logical sections and separate them into pieces that we can recombine and reuse. Functions allow us to keep the program size from becoming too large, so we don't have, and it allows us to employ the programming principle of don't repeat yourself, the dry principle. And we're going to learn functions in C++1, and they will be the building blocks for building classes later on when you take C++2. There's a set of integrated libraries in C++ that you get right away without having to download and import libraries from another source, and they give you a lot of functionality. This class is set up to prepare you for learning object-oriented programming in the next semester. And so it's kind of important to understand a little bit about object-oriented programming at the beginning. Before object-oriented programming, programs tended to just be basically a set of instructions for the machine to execute, and it's called a structured programming approach or top-down approach. In object-oriented programming, one of the challenges with that, of course, was that you could have extremely long programs. If you think about problems that need to be solved, they could become very long and very hard to debug, and maybe be kind of repetitive. And so one of the ways to organize that was to model the program after the things in the real world it was designed to work with, and break the code up into objects. And each object was the code used to represent something in the real world. And the way you could think of an object is something in the real world. And if multiple objects kind of behave the same, then you could define a class for those objects, and that class was kind of the job description for how those objects behave. So a read-writer job or class would have the information and tools to know how to open, read from, and close files. A calculator class might have be structured to do calculations. And so here's an example of maybe a class that would, or of a reader-writer object. Martha opens and reads the data from the files, passes the data to Don. Don waits for the data to be passed to him. He performs the calculations and determines the answers. So Don is the calculator, and Martha is the file reader. And then Don passes the answers back to Martha. Martha then writes the answers to the file and closes it. And you can see from that example that Martha, the file reader and writer, is worried about retrieving and storing information, and Don, it's the calculator, is worried. He doesn't care about whether he's getting information from files or something else. He just worries about calculation. And the result is that it separates the problems into a smaller subset. And so we like using object-oriented programming because if you're working with a very complex problem and you have a number of programmers that are working on it, you can break the problem up into objects, into classes, and then assign the classes to different programmers to write. And because each class is independent of the other classes, a programmer can write the code for that class and not have to worry about what the other programmers are doing. Here's a structured example, an ATM, and you can see here this is basically describing step by step what a typical ATM interaction is like. You insert your card, you enter your PIN, the machine validates your PIN and account. You select the cash to withdraw, you enter the amount, the balance is verified, money is dispensed, a new balance is calculated, a receipt is received, and you return the card. So that's a structured approach, and it's basically a step-by-step approach. Perfectly good way to solve the problem. However, it would be nice to be able to maybe break that apart. And in order to do that, what you do is you ask who does what, whose job is it, who inserts a card, who reads a card, who verifies. So each step you look at it and ask who does that, and then the answer to that tells you which class that step belongs into. If you do that process, you end up having something like this, where you have a bank customer, the ATM, and the bank. And you can see the bank customer, from their perspective, all they do is they insert a card, put in their PIN, select the cash, enter the amount, take money, take the receipt, and take the card. And that's all they do. The ATM reads the card, obtains the PIN, contacts banks for validation, obtains selection, bank for validation, obtains selection and cash amount, dispenses the money, and writes a receipt. So you can see Now we have a little bit more useful perspective on how to write this code. We're not going to write the code for the bank customer. The human being already knows how to do that sort of thing. We're going to write the code for the ATM, and then we also need a component in the bank. And all the bank code does is just verify the PIN and account, check the balance, and then adjust balance. And it's just sitting there just doing that. So this breaks the problem down to 3 simple pieces and simplifies our understanding of the problem. And you can see that the transactions kind of flow back and forth between the different classes and objects. So a bank customer will talk to the ATM, and then the ATM will also talk to the bank. And these interactions flow back and forth between the different functions of the classes. So the advantage of designing from an object-oriented perspective are that objects perform the task, code is broken up into functions, and objects interact to produce the desired results. So we say that objects are the things that perform the task. And by writing a class rather than writing just the code for C++ Bank, we write it as a class. Then any ATM can interact with any other bank because these banks will all have a class that will interact with the ATM. And since you're using the same class, we're just instantiating multiple objects for each of the banks, then we can reuse the code. Here's another example. We have a structured example of car maintenance. Call the shop, schedule an appointment, take the car to the shop, check in and write the ticket, take the car to service area, examine the car for maintenance. And you can see as you go through here, it goes all the way through to the person paying their bill and getting their keys and driving home. So again, applying the same principle, who does what? Well, the car owner really, if you're thinking from their perspective, they call the auto shop, take the car to the shop, pay the bill, and drive home. The shop manager does these things: scheduling appointments, writing up the ticket, take the car to the service area, calculating bills, call owner, go to repair. And then the mechanic, from their perspective, they get a car, they fix it, they write up a report, and then go on to the next car. So this breaks the problem down. And again, we're using that principle. Whose job is it? And then associating each of the tasks with the class that it belongs to. Write these as classes, and then we get multiple mechanics and multiple managers and multiple car owners, and they can all interact. So that's the basic idea behind object-oriented programming. We're going to use some classes and objects in this course, and then next semester you will learn how to actually write your own classes. So one of the things that we need to do to become programmers is research solutions. As a programmer, it's your job to figure it out, and that means that you need to be able to go look things up. There's a lot of online resources for programming, and arguably one of the primary purposes of the internet was to make documentation easily available to people. And so MSDN is the Microsoft Developer Network. That's one source for information about C++. There's also websites like c++.com, and then Bjarne Stroop's own website is another source for C++. So I recommend that whenever you learn anything new in programming, you go look it up in the documentation and read the documentation. Often documentation is not easy to read. It's written with the assumption that someone already knows the material. And so it takes a little bit to learn how to read the documentation. So as you're reading your textbook, it's a good idea to also look up the material in the documentation as well. Troubleshooting. So there's some do's and don'ts for programming. It's usually a bad idea just to sit down at the computer and just start trying to slam out your program. You probably want to do some work beforehand. It's useful sometimes to write on paper what you need to do. You might want to write a pseudocode algorithm for your overall program, not worrying about the syntax, but just writing out what your program needs to do and breaking the problem down. Do some calculations on paper to figure out how to do the mathematical components, and then starting to solve the problem a piece at a time. Don't avoid comments in your code. In fact, I recommend using your comments to lay out your program before you even start typing, and then you can write your comments as a series of problem statements to solve your program, and then solve each one as you go. Frustration. You're going to experience frustration as a programmer. Get used to it and accept it as part of the process. When you get frustrated, sometimes you need to step away the program. It's amazing how often you can't find a problem in your code. You walk away for 5 minutes, come back, and it's just right there. Your mind will adapt to what you're looking at, and it won't see it as well. And sometimes you have to switch gears. Go work on a different assignment in a different course and come back is a great strategy for giving your mind a rest on your program. Test everything, even if it's a simple just outputting your header to the screen. After you write those 3 lines of code, run the program and see it execute. I highly recommend that you are executing and running your code after every 3 to 5 lines of code that you write. Do be meticulously neat about the way you write your code. If you keep everything lined up, you're going to find that you're going to code faster, because one of the primary time wasters as a programmer is trying to find a missing curly brace, and often that happens because your code is a little bit of a mess. And then also plan on working on your program over the course of several days. As soon as you get an assignment, you should be immediately trying to find 15 minutes that day to throw at the problem. This allows you to get to start processing the program in your mind as you go out throughout your day. Much of the work you're doing to solve the problem will happen when you're not even sitting at the computer, when you're just walking around. But your mind can't do that for you if you don't start working on the program right away and give yourself multiple opportunities over the 1 or 2 weeks you have to solve the program to actually work on it. So plan on working on your program in multiple batches. If you make a change in your code, test a change. Hit run right away. It's free to run your program. You should do it frequently. And realize every time you change your code, it may mess something up in your code. And part of the art of writing code well is making it so that when you change one thing, it's not going to affect other things. So breaking down your problem at the beginning can help with that. In my presentations, I'll have Socratic questions. In this video format, I'm not going to have you go to Socrative, but we will use that in the classroom. Instead, what we'll do is I will present the question and give you an opportunity to respond to it. I recommend you pause it, think of the answer, and then continue running the video. So let's start with the Socrative question. What is the best strategy for developing software? Wait till the last moment. Try to write the program all in one sitting late into the night, depending on your own ability and lots of caffeine to get you through. Turn it in without testing to save time, or start as soon as you get the assignment. Plan ahead and to schedule many sessions of coding and ask for help early, and especially if it's taking you a long time to figure something out. And then test. So think about the answer. And then clearly, I would recommend strategy 2. Strategy 1 is often frequently used, writing at the last minute, but this is extremely painful. I recommend starting as soon as you get the assignment and give yourself plenty of time to work on the program in small batches. Okay, next question. Who was the designer and original implementer of C++? So we have Von Neumann, Grace Hopper, Bjarne Stroustrup, and John McCarthy. So think about the answer and pause if you need to. And the answer is Bjarne Stroustrup. Bjarne Stroustrup was the original designer and implementer of C++. So that's what we went over today. Thank you very much, and I hope you enjoy the course.